This is Physics and Reso. Let's talk about resistance in series and resistance in parallel. So basically, I'm going to show you how can you derive the two formulas shown here, and these formula represent the general formula for resistance in series and resistance in parallel. Now, without wasting time, let's get started. So basically, we have the diagram, and this illustration represents resistance in series. They are connected end to end with the resistors are 1, R2, and R3, and they have the potential difference V1, V2, and V3 across their terminals. And the special thing about the resistance in series is that they always have the same current. But they always have this different potential difference. Or sometimes you can just represent it as V. It is true for the physicist. It is known. And having seen that fact, now let's go ahead and to derive the formula now. Alright, so according to Ohm's law, we know that in order to find the potential difference, we basically know that the potential difference is given by the product of the current and the resistance. And these are now the, well, sometimes we call it equivalent resistors, but now I'm going to say that the total resistance in this entire network. Alright, so it's obvious that the total voltage across the entire network is given by the sum of the current, the sum of the potential difference across these resistors. So that's clear. Now let's say that V1 is basically given by I multiplied by R1, and V2 is given by I multiplied by R2, and finally V3 is given by I multiplied by R3. And then we can just plug in these values to this formula, which of course I have just numbered it as, well, equation 1, but I don't want to waste time. So basically V, as we've shown from here, B is basically I R, and as I've told you that this R is the equivalent resistance, then it's be given by, let's plug this value for R, V1, V2, and V3. Yes, to make things clear, R1 plus R2, IR2 plus IR3. And then, as we can see, I is common for both equations. Well, in both sides, I can say. Then we can just factor it out from this formula. So let's do this. And then we can just cancel it, and then we remain with R, which is the equivalent resistor, or you can say R total is R1 plus R2 plus R3. And then you can just go ahead and put any number of resistors that you want, because this formula holds true for any number of resistors that you put in. And then I'm going to represent as Rn, whereas N represents any number of resistors. Well, resistors rather. Right, so this is the formula now. We have derived it. It's quite simple. Just to recapitulate what I just said before, well, a while ago, that for the resistors arranged in series, they always have the same current, but they have different potential difference across their terminals. So having seen that formula, now let's go ahead and find the other formula for calculating the resistors. Well, the general formula for calculating the resistance in parallel. And this diagram, the next diagram, represents the resistors arranged in parallel, and let's name these resistors as R1, this as R2, and this as R3. Right, and then they have the current I flowing through these resistors, and R3 and R1, R2, R3, they have the current I1, I2, and I3. Right, so now of course I can, let me just reverse the order. Let's say this is R1, this is R2, this is R3, so that I can just make it things simple. I don't want to confuse my viewers. And then the special thing about the resistors arranged in parallel is that they always have the same potential difference but different currents flowing through these resistors. It's just the opposite of the resistors arranged in series, so don't get confused, and that's how you can derive the formula. It's quite easy. So you use the difference in the potential difference or the current to come up with the general formula, which is pretty simple. Now again, we know that the total current flowing through this resistor, or this you can call as input current, and after summing up all the current through these resistors R1, R2, and R3, we come up to the same current output with the same magnitude. So we know that the sum of all the current flowing through the three resistors. So this is basically I1 plus I2 plus I3. That's clear. And then, you know, from Ohm's law, we know that I is basically V of R, whereas R is just the equivalent resistance. So we can go ahead and say that I1 would be V over R1, and I2 be V over R2, and I3 be V over R3. So just mark these values of the currents, and then we're now going to substitute these values to our equation here, which relates the total current through this network. So we can go ahead and say that let's plug I in here. So we have V over R, which are the equivalent resistance. Then we have V over R1 plus V over R2 plus V over R3. And then you can see that V is the common variable. Now we can just take the reciprocal of V, and then we cancel out V straight away. And then using your mathematics skill, we can say that 1 over V, then you multiply by this stuff, V over R. Then this turns out that V over R1 is just 1 over V over R1. And then you do the same thing to the rest of the resistors. Let me do it that way. Now you can see that we can cancel V as shown. Yes, cancel them out because the R is out, right? And then we can just rewrite the general formula. Remember, we want to take 1 multiplied by V over VR. We just remain with 1 over R. Then we remain with 1 over R1 plus 1 over R2 plus 1 over R3. And then you can go ahead and put any number of resistors that you want. whereas n represents the number of resistors that you may wish to plug in. You can plug in 1,000, 10,000. It's by your wish. This formula will always hold true for any number of resistors. Right, so this is the general formula now for the resistors in parallel. Now guys, you can see it's very simple. You can't waste your time, well, some 20 minutes drive this formula. It's quite simple. It's you combining it with mathematical skills and, well, physics skills, especially when you have studied the late current topic clearly. So I'd like to remind you that you can like, comment and subscribe for more tutorials that are going to come up in Phys Universal. Please stay tuned to Phys Universal for more wonder stuff that will blow your mind. For now, I say bye bye.